Alrighty, hello again. So today we're going to be covering the data set that we're going to be using logistic regression on, and it is a very nice data set, and it's one of the most interesting data sets that I've ever worked with. We're working with the Titanic data set. So we're going to have the data from all of the passengers that were on board the Titanic when it sank back in 1912, I believe, is when it sank. Um, so some backstory: you had uh, something like 2,200 passengers and crew on the Titanic, and when it sank in the North Atlantic, it took 1,500, over 1,500 people down with it. So the survival rate was not great if you were on board the Titanic at that time. So uh, if y'all are ready, we can kind of dive into the data. The first thing that I want to do is talk a little bit about what the data set looks like. So I am going to mention that this data set has been cleaned by me already. The original data set was a little bit messy. It had some categories that really weren't useful for it for our logistic regression, and so the data set has been completely cleaned. Everything is nice and neat. Any missing values were either averaged, as in the case of an age, or completely taken out, like which cabin the people were located in. So let's look at the data set for just a second. Okay, so if you want, you can also open this up inside of Excel. It's it's a perfectly good viewer for a CSV data, just comma separated value data. So here we go. We have over in the data uh, the different headers, the passenger number, which is not important. It's just a way of numbering all the different passengers. You have the survived. Zero means that they did not survive the Titanic sinking, one that they did. You have P class. P class is the passenger class, and it ranges from values of 1, 2, or 3. So first class passengers typically corresponded to upper social economic status, second class, middle class, and third class was lower class. So that P class is just socio economic status of the passengers. The age, pretty self-explanatory, of the passengers. If the value was missing, I just I put in the average of the ages. This avoids it being either too low or too high, which, as you can imagine, being below a certain age or above a certain age can definitely affect whether or not you survived the Titanic. Um, the SIBSP category. So this one, it counts the number of siblings and spouses that you had on board. So brothers and sisters and husbands and wives. Three means that you had three brothers and sisters and or a spouse to go with them. So that's the SIBSPA data category. And then when we move to the next one, the PARCH category, we have uh, parents and children. So a number of parents and children that were on board the Titanic. Uh, and you can see down in the data, there are some fairly large families that were on board the Titanic. That actually affected whether or not everyone survived. So the other category, the next one, is the fare. This is how much they paid for their fare. This is a really good value to have because it breaks down how much they paid for their tickets, and something completely independent of the perceived socioeconomic status. And the next category is the category for the sex of the passenger. It's titled male. If it's a 1, the passenger was male. If it's a 0, the passenger was female. And finally, the last two. So the Q stands for Queenstown, and the S stands for Southampton. So these were the points of departure. These are where the passengers actually got on board the Titanic. So the Titanic started off in Southampton, England, and then it picked up passengers, and those are denoted by 1 in the S column. And so then it went from the Southampton, England, down to Cherbourg, France, and that is a Cherbourg starts with a C, which is very confusing. Notice there is no C category though, so it picked up passengers at the C category and then swung up to Queenstown, the Q category here. And then after it left Queenstown, it started heading across the North Atlantic, and that's when it sank. So the S category corresponds to people that embarked on the ship at Southampton, and the very first stop, Q for Queenstown in Ireland, and that was the last stop. And if there are zeros in both of these, that means they either got on right before Queenstown, right before rather Southampton, or in Cherbourg, France. So it could have been either one of those. But this is kind of an interesting set of columns here for information, because this tells you, did they get on at the beginning of the journey, and if it's a 1 in the S, or at the end of before they head across the North Atlantic in Queenstown, Ireland. So that might actually affect the data. I won't spoil it for you whether it does or not. So this is our clean Titanic data, and after this we're going to move over into the actual code and see what we get. So here we go. Okay, here we are back with our data. This is inside Spider, as always, and we have all of the code down here that I'll be sending out. It's pretty simple and clean code, so it shouldn't be too bad. We're going to first use pandas to read the data in. Pandas is pretty much the standard for reading in your large data sets that contain alphanumeric data. It's just, and honestly, it's become used so much, it's used even in the case of straight numeric data. So we're going to use pandas to read in the CSV file, the clean titanic.csv, which is the data file that we opened up in Excel. And we are going to use when we read the data set in, we're going to have all of the categories that are making the prediction that are containing the data that we use to make a prediction whether or not someone survived are going to go into our X variable here, and then whether or not they survive, the 1 or the 0 that will be used by logistic regression, it's going to be stored in the Y value. So we have all the predictive columns in X and the column that contains whether or not someone survived as our Y. And now that we have our data formatted that way, we are going to call one of the most commonly used of all the libraries, the commonly used functions. That is the train test split. And so from sklearn, need to mention that. So what the train test split does is it takes your data and will split the data into a test set and a train set. So the training set will be used with the logistic regression model to actually train the model, and then it will validate whether or not it can make good predictions, how accurate its predictions are with the test set. And so we get you need the same amount of values, and it needs to correspond to match up for your X test and Y test, and your X train and your Y train. So it splits up the data completely randomly, and the way that it splits the data up, we have it set right here in this parameter, test size equals 0.3. So 30% of our data is going to be held back in order to test the accuracy of the model that trains on the other 70% of our data. So this train test split does everything for you. You literally feed in which of the variables holds all of the predictive columns, and then which variable has the actual value that will be used by logistic regression to say whether or not someone survived or did not, and the percentage of your data that you want to hold back to test against. That's it. That's how a training test split works. Super easy to implement, wonderful function. And now that we have all of our data split into X train and Y train for the predictive values and the actual survival, that can be used by our model to train the model with, and then the test stuff to actually verify how accurate the model is doing. So now that we have that, we can import the logistic regression model from sklearn. We just have, we're doing a linear solver here. There are other types of solvers that you can specify here, but for our data, for the simple data that we have here, this solver works perfectly fine. We're going to basically assign the function to log model, and then log model will have an operation here, log model.fit, and what is it going to fit against? Well, the X train and the Y train. So the X train are the predictive values that are stored in the training, and then the Y value are the actual values of ones and zeros that were split into the training set. So we fit the model with the X train, Y train values, and then we're going to make our prediction, which is going to be stored in Y underscore pred, Y prediction. That's going to be the log model.predict, and it's going to predict versus the X test. So the actual ones and zeros that were withheld for the test set to see how well it did. So after we do that, it has now, with these few lines, trained the model and tested the model to see how well it did. And so it trained the model with these two lines right here, and then it made tested the prediction, the accuracy of the model with this line right here. Okay, the only thing that's left is actually see how well it did. So for that, we're going to import metrics from sklearn, which is chock full of tons of ways that you can analyze your data. We're doing by far the simplest version, and we just want an accuracy score. And the accuracy score is going to be how well did it do comparing its predicted Y values versus the actual Y values that are in the test set. So that's it. And now we are free to run it. So I'm going to go up here and run it, and let's see what we get. And there we go. We got an accuracy of 76%. Not bad. Not bad at all. Now, this is using all of the columns to train the model with, and the simplest form of everything. So 76, not too bad, but I want to show you what happens if I run it again. So now if I run it again, well, I get 80.9% accuracy. Okay, the reason that they're different is because when you do the train test split, it randomly assigns 70% of the data to the training side and holds back 30 for the testing side. And so since it's completely random, we're going to get a different value for the accuracy every single time we run the model. If I keep running it, yeah, you can see that one is almost spot on, but that one's different. And if I keep running it, it'll get different values the entire time. Oh, that's an 82%, not too bad. So that's the basic way that this is working. Now, to have fun with this data a little bit, we're going to do some of the easiest ways to alter this that we can think of. If I want to, I can take the test size and tweak that, and maybe only hold back 20% of the data. If I do that and run it, well, does not appear that it's doing that much difference. We still are getting into the high 70s. Actually, it looks like it might be a little bit worse. I could change that to 0.25 or 0.25 and run it. But 30% is a good rule of thumb, you know. So we're going to leave that as 0.3. But here's the fun part. Now, let's say we wanted to see which one of these categories actually helped predict whether or not someone survived the most. Which one of these is the has the most effect on whether or not someone survived. And so the way that we can do that, it's not difficult at all, is I'm going to take this line, I'm going to copy it with Control-C, and then I'm going to re-enter it, and then I'm going to comment the original one out. Now I have, this is kind of like holding the actual code in stasis while I mess around with all this. So what I'm going to do now is take out all of these variables and just leave P class. Let's see if the passenger class, if we can make accurate predictions of who lived and survived just with that. So come over here and run it, and yeah, 69, 69, 70, yeah, nowhere near as accurate, which that's to be expected. Just having a single column data is, you're definitely going to wind up with a worse model when there's a wealth of information from all the other ones here. But now we can play around with this. We can have age and see how that does. Let's see here, get that up, run it. Oh, yeah. That's even worse, just having age. So turns out age was not a big predictor on who lived and who died. But as you can imagine, there are some of these that are definitely going to have a large effect. Let's look to see if the sex of the passenger had anything to do with it. Yeah. 78, 82, 81. And now let's contrast that with the fare that they paid. So this should be a better indicator than just the P class. So 65, not a huge indicator. And finally, just because I want to see if that has anything to do with it, I'm going to just do the Q and the S, the embarkment departure cities, and see if that has any predictive value. Well, not too bad. High 60s, high 50s. Yeah, no, not very much. But we probably had an idea that that would be the case, because if I look at the sex of the passenger again, I get back really high values, high 70s for my prediction, even low 80s, which is about what the entire model did. And now if I want to go back to look at the entire model, I comment out this one, come up here and uncomment that, and then run it again. And let's see what we get. Yeah, we get high 70s, low 80s, back again. So feel free to play around with this data all you want. It is a lot of, I thoroughly enjoy playing with data sets like this. And there are ways that we could, to actually look at, figure out which of the variables had the most predictive power. But this is just a simple example to play around with, to get an idea of what logistic regression is doing and how you can use it to make predictions. So that's about it. The very next video will be finally moving into neural networks, and I will see you then. Take care.